Good afternoon, everyone, depending on where you are joining us from. And on behalf of the Environmental Finance Center Network, I want to welcome you all to our webinar today on Math and Hydraulics for Wastewater Operations, Understanding and Completing Reports in NetDMR. So we are going to go ahead and get started. So my name is Avery Davis from the Syracuse University Environmental Finance Center. And before we begin, I'm going to cover a few logistical items and then I will hand it over. So during the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We'll be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will all receive a follow-up email that includes a link to the recording and other information you may need. You can also download the slides from today, as well as a handout that will be used in a more hands-on exercise later in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire webinar and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. And if you have any questions or need assistance, please contact us at smallsystems@syr.edu. Lastly, now for a little bit about the Environmental Finance Center Network. We provide training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and financial capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. And on that note, I would like to introduce our presenter for today. So we have KT Newman, who is the owner of Utility Contractors, LLC. So welcome, KT, and I hand everything over to you. I think you're still on mute. Oh, there you go.
Thank you, Avery. Thank you for the introduction. My name is KT Newman. As stated, I am the owner of Utility Contractors, LLC. My experience in the water and wastewater industry goes back approximately 26 years in a number of capacities, all of which involved in some aspect or another management and technical assistance to water and wastewater systems across the state of Mississippi. I am thankful for the opportunity to join you today and look forward to future endeavors as well. And I would also like to welcome all of you that are attending virtually. Our topic for today is math and hydraulics for wastewater operators, but our emphasis is going to be on NetDMR, understanding and completing reports in NetDMR. Now, I'm sure all of you are familiar with NetDMR. We've been submitting our reports via NetDMR since 2016, I believe, but we just want to talk about some of the nuances that occur in the submitting of the data and possibly help us to alleviate some of the errors that occur in that process. So during this presentation, we're going to be reading and understanding the reporting requirements of NetDMR. We're going to discuss the importance of data management, as well as finally, at the conclusion of the presentation, we're going to be actually performing some calculations. So that will hopefully be the highlight of this presentation when we actually start the calculations. So what is NetDMR? NetDMR is a web-based tool that allows facilities to electronically sign and submit discharge monitoring reports. It's a web application that can be used to enter and submit data required to meet the reporting requirements of the NPDES permit. Is NetDMR required? By and large, the answer to that question is yes. If your facility is required to report conditions of the NPDES permit, then without fail, that's to be done through NetDMR. The benefits of NetDMR, one immediate benefit that alarms is the paperwork reduction. If you remember, prior to NetDMR, it was a heck of a lot of paperwork. NetDMR reduces that considerably. Not only that, but it improves the timeliness and accessibility of data. Data quality is improved by automatically error checking and validating data prior to submittal. And perhaps one of the biggest benefits is that submittals are easily accessible and can be revised electronically. One of the biggest drivers of NPDES non-compliance is failure to properly submit a discharge monitoring report. So why is this important? The answer is compliance, compliance, compliance. More than half of all the NPDES violations that occurred are reporting related. The movement of data from the lab where it is originally collected to the DMR can create lots of opportunities for error. From the collection of the sample to the sample being analyzed by the lab to the data being reported on the NetDMR provides a lot of opportunities for error. Nevertheless, it is your responsibility to check the data that we're plugging in to make sure that it is accurate. There are a number of factors that contribute to reporting problems. Could be miscalibrated equipment, poor data management, or a number of other reasons. Today's focus, however, is on what many believe is the biggest reason. It's rarely the case that units in your permit will line up exactly with the units in your raw sampling data. You'll need to perform calculations to convert that data to the units required in the permit. But when those calculations are performed by hand, they can be a major source of errors. At this point, we're going to perform a hands-on exercise. During this exercise, or even when you're completing your own NetDMRs, these are the things that you will need to have at your disposal in order to continue the process. You'll need your lab results. You'll need your operator log data. You'll need a copy of your NPDES permit. And of course, you'll need paper, pen, and the calculator. At this time, we're going to switch over to the NetDMR to give you an idea of what that looks like. Scroll the whole page down. First one down. Scroll down. Okay, now, as you can see, we're actually in NetDMR, ready to enter data. We will not enter data at this particular time, but we're going to go through the calculations as if we were entering data. The first parameter is dissolved oxygen, effluent dissolved oxygen. If you notice, we're not going to enter anything here. On effluent dissolved oxygen, this is a monthly sampling requirement, a monthly sampling requirement. If you move down to the next parameter, you'll see dissolved oxygen in the aeration unit. This is influent dissolved oxygen, and it is a weekday parameter. So in your operator log, you'll have 5 entries for every 7-day period. Continuing down, effluent BOD, as the name suggests, this is an effluent parameter that's also monthly. And also, let me mention this on the dissolved oxygen, the permit has a 6.0 milligram per liter minimum. You'll have this particular facility monitored on a quarterly basis. So you'll have 3 samples for every quarter, 1 sample per month for 3 months. And we will input the minimum the result there. On the BOD effluent, notice on this that we've got a quality or concentration. Also, we've got a quantity or loading. The quality will represent the data that you will find on your lab results. And most likely the units of those tests will be in milligrams per liter. However, it's your responsibility to make sure that the units that are on your permit, that you report in those same units, regardless of what units those lab results happen to be in. So the effluent BOD limit for this facility is a 10.0 milligram per liter max monthly and a 15 milligram per liter max weekly. Now, max monthly and max weekly tend to be a bit confusing, but it does not have to be. In this particular instance, this facility is sampling on a monthly basis. If you only collected 1 sample that month, then the maximum monthly and the maximum weekly would be the same. If, however, for some reason you collected more than 1 sample that particular month, then you would have to average those, however many samples you collected, you would have to average those to get the max monthly. And assuming you did not collect more than 1 sample in a week, then the highest given sample would be your max weekly. Continuing down, you've got your BOD influent. Of course, there's not any permit limits on the BOD influent, but there are reporting requirements. Let me mention this on the loading. The loading, of course, is a calculation that has to be performed that includes the flow. So on your sampling data from your lab, there should be information that would indicate the flow on that particular day. You'll need that information in order to calculate the loading. Continue down to pH. pH, of course, is a permit requirement with a 6.0 minimum, a 9.0 maximum. Now, one thing that differentiates pH from the other parameters is that the pH has to be recorded within 15 minutes of collection. So it may be that the lab will collect all of the other parameters, but the operator may actually collect the pH. And it is also a weekday requirement, weekday meaning 5 out of 7 days. Total suspended solids effluent is similar to BOD effluent in that it is also a monthly requirement. As you can see, there's a 30 milligram per liter max monthly, a 45 milligram per liter max weekly. And that max monthly and max weekly will apply if for some reason during a particular month more than one sample is collected. If there's only one sample collected, the max monthly and the max weekly are the same. Suspended solids influent, very similar to the BOD. There are no influent permit limits on this particular facility. So you're going to report without limit. Move down to the nutrients, total nitrogen. If you notice on this particular DMR, there are no quality limits. There are, however, loading limits. If you notice that there's a 71.98 max monthly and a 107.97 max weekly. There are loading limits, but there's no concentration limit. Moving down to total nitrogen influent, as is the case with all of the influent parameters, they report only monthly. If you look to the far right of the DMR, you'll see 1 out of 30 means monthly. Let me mention this as well. Notice that all of these samples so far, with the exception of pH and DO, are composite samples, 24-hour composite samples, in fact. So pay attention to that as well. We don't want to collect graph samples for a sample that should be a composite. So that too are some of the more common areas that you may encounter when completing DMRs. Next, you've got ammonia nitrogen effluent. This facility has a relatively low limit of 2.0 maximum, 3.0, 2.0 max monthly, 3.0 max weekly. And it is also a monthly sampling requirement. Okay, I'm going to switch over to page 2. Go back to the top. Continuing with the NetDMR, we discussed our ammonia nitrogen effluent. Now we've got to report our ammonia nitrogen influent. Like all the other influents, it's report only. Another nutrient, total phosphorus. Just like total nitrogen, total phosphorus does not have a concentration requirement or limit, but it does in fact have a loading limit. Phosphorus, and it's also a monthly sample. Total phosphorus influent, report only. Flow. The flow is a weekday requirement. As you can see, the max monthly is 0.75 mgd. The max weekly, there is no limit on max weekly, but the max monthly is a 0.75. So this facility is permitted at 0.75 mgd. Total chlorine residual. This is also a weekday requirement, 5 out of 7 days. And if you notice, the permit limits are pretty low, 0.011 max monthly, 0.019 max weekly. So to meet a chlorine residual that low, you would also have to dechlorinate. So this facility chlorinates and dechlorinates in order to meet an average that low. The next parameter, of course, is E. coli with a 126 max monthly and a 410 max weekly. The thing of note on E. coli is this. If you've only collected one sample during the month, then the max monthly and the max weekly averages will be the same. However, if for some reason you collect more than one sample and you need to average, then E. coli fecal are not, you average these by geometric mean. I would advise you, if you have to do that, you can log on and find a geometric mean calculator that can take all the guesswork out of that. But the key to remember there is that if you have to average more than one sample, it's a geometric mean. Moving down to the next two requirements, they're monthly percent removal of BOD, percent removal of total suspended solids. In a nutshell, percent removal measures how efficiently this facility is operating. For example, you've got 200 milligrams per liter of BOD entering the facility. You've got 10 milligrams per liter or 5 milligrams per liter or 20 milligrams per liter, whatever the case may be. What percentage of that BOD was removed? We're gonna do some examples of that here shortly. Suspended solids, of course, one thing to note on this particular permit, the percent removal requirement for both BOD as well as TSS is 85%. This, by the way, is a mechanical plant. It's an oxidation ditch, which typically activated sludge plants will have a higher, naturally will have a higher percent removal requirement than a lagoon. Finally, a sludge settability, 30-minute settability. This is a reporting requirement that's used as an operator to help troubleshoot how well the plant is working. Notice that there are no permit requirements on 30-minute settability. It's reporting only, minimum as well as a maximum. Now, one thing that I failed to mention, and that, by the way, is also a weekday requirement. One of the things that I failed to mention, go back to the top, is that the DMR also allows you to input the number of exceedances. For the most part, 0 will be the number of exceedances, hopefully, but from time to time, for various reasons, you may very well get a result that's outside of the permit limits. And of course, you'll have an opportunity to explain and even correct. However, if you've got an exceedance, whether that be 1, 2, 3, 5, or 0, that information will go in the blank of number of exceedances. So be mindful of that as well. And notice that the total nitrogen, ammonia, the nutrients, all of these are 24-hour composites. Your graph samples will be your DO, your pH, and your chlorine, of course, and E. coli. So that in a nutshell is what the NetDMR looks like. Another thing that I mentioned earlier that I would like to stress yet again is that, we've talked pretty much about the quality or the concentration, which that information is coming directly off of your sample results from the lab. However, the quantity or the loading, this is information that you'll have to calculate. You'll calculate that based on the flow on the particular day and time that the sample was collected. And one of the things that I'd like to point out to you is that, and of course on this DMR, when we get to the sample results, one of the things that we're going to point out is that for this particular facility, for example, there are 3 influent samples, 3 effluent samples. You can have the highest effluent concentration does not necessarily mean the highest loading. You have to calculate each one and determine the loading, because the flow may have been higher on a day where the concentration was actually lower, meaning that it could result in the loading being higher. But we'll have an opportunity to explain that once we go to the board and start doing a few of the calculations. So keep that in mind, that the highest quality or the highest concentration does not always mean the highest loading. Okay, so once you've entered all of that information, another one of the benefits of NetDMR is if you enter information that's outside the permit limits, it will alert you. If you skip a parameter and don't enter any data at all, it will alert you. So just those 2 things alone allows you to submit reports that are more accurate, because in many instances it won't let you continue until you address any of the warnings that may have been created through the process. So keep all of that in mind. Pay attention to those alerts or warnings or validation errors, as they are referred to, as you're submitting this information. Now, let's take a look at some sample data. Okay, this particular facility, as we mentioned before, is a samples monthly, but reports quarterly. Now, some of your facilities may sample monthly and report monthly. Some of your facilities may sample yearly and report yearly. By and large, most of the facilities in Mississippi will sample quarterly and report yearly. But the particulars of that will be laid out in your permit. And when all else fails, the permit is right. So pay attention to your permit and make sure that the DMR, as well as the information that the lab is providing you, is consistent with the permit requirements. So as you see on this particular sample results that were collected in April of 2021, you see the influent parameters that were sampled or collected and sampled by the lab. And we'll move down. And these, of course, are the effluent parameters on that same day. Notice that some of the information, some of the need to know information, I took the liberty of penciling in at the bottom of the lab results, if the lab did not record it. For example, the DO on the effluent DO on that particular day was 8.6. And actually, it doesn't have to be on that particular day, just at some point during that month. The pH was recorded as 7.8, and the flow was 0.43 mgd. Now, that flow is important, very important, because this is the information that you will use in calculating your loading. Go down to the next one.
KT, I have a question.
Sure.
For attendee. So they asked if the lab submits a .csv or comma delineated file, can the DMR import that data directly?
What was the question?
She's asking if there's an electronic file, can you simply upload the lab report into the DMR?
I don't think that feature is available. However, you can upload attachments to the DMR if you've got a violation or an issue that you would like to offer some comments as to why, or explain or show what you've done to correct it. There is an opportunity for you to attach supporting documentation, but I don't know that you can upload those results directly to DMR. At least we don't have the capabilities of doing that as of yet. If that answers the question.
Yes, it does. Thank you so much.
Thank you. Finally, go back to the final set of parameters would be E. coli. And as you can see from these results, and in fact, go back up. I want to show you one other thing. Yeah. If you notice on BOD, if you notice on the BOD and also on the E. coli, you see that less than sign. Typically what that means is that the result was lower than what they're capable of reporting. In this case, BOD of 6 will be entered, effluent BOD of 6 will be entered on our report. However, the actual number could be less than that. The lab is not, in this instance, was not capable of reporting a number less than that. Same is the case with the E. coli. We'll look at that one more time. On the E. coli, you see that E. coli is measured by most probable number, colonies per 100 milliliters, less than 1. And actually, I want to switch back to NetDMR for a second. I want to show you something there. All right, go back to page 1. Go there. When you particularly, go back to the top. One thing of particular importance, pick those NODI, are your NODI codes. I don't know how often or how familiar, see NODI, go over, NODI. Under number 1. You see number 1 up there? Go up, straight up from there, straight up. Right there, click that list. All right, these are your NODI indicators. If for some reason, from time to time, you'll run into situations where you're not able to input an actual number. For example, some of the more common entries in NODI, NODI-B. That, in this particular instance, NODI-B would be what we enter for our E. coli, because the level reported by the lab was below detection. Another common NODI code is NODI C. Sometimes if you've got smaller facilities without a lot of flow, you may go through months or quarters or even longer periods of time without any discharge at all. So if you don't have a discharge, then you're looking at a NODI C. Now, there are some other NODI codes. Hopefully you don't find yourself having to use these. For example, a NODI E. If by chance there's a parameter on your permit that you fail to conduct an analysis for, that's what the NODI E code, where the NODI E code will apply. Again, hopefully that's not something that you're encountering with very often, but it does happen. And it most often happens when the permit renews. Sometimes a permit will renew and there's a miscommunication between the facility and the lab, and there may be some new requirements, particularly with nutrients. There was a time not long ago when nutrients, total phosphorus, total nitrogen, were not parameters on the permit, but when the permit renewed, they were added, and there were some facilities that had to report as a NODI E just for failure to conduct those particular samples. So again, you can eliminate that issue by making sure that there's a clear communication between the lab and the facility, and that all parties have access to the permit. That again is the driving force behind compliance, and we want to make sure that we're all on the same page in that regard. So go back to the NetDMR just for an example. We want to go down to fecal. Or E. coli, I'm sorry. Go back up. It's on page 1. And, 2, go to 2B. Exit out. Hit the arrow button back. Just go there. E. coli. If you noticed, if you remember from our results, we didn't look at all 3 months, but and I don't know if you have access to that or not, but all 3 months showed no detect or less than 1 colony per 100. So under E. coli, we're going to click on NODI. And then we're going to check B, below detection. And that's how you report a number that's below the level of detection. Now, if you noticed, our BOD was also a less than 6, but rather than report a NODI on the BOD, we're going to put in a 6 because we've actually got to calculate some loading off of those BODs. So that 6 would be more appropriate in that instance. Okay. So that in a nutshell is what NetDMR looks like. You know, some of the issues that you may find yourself. Of course, on the quantity or loading cycle, back up. The flow is reported in MGD. Now that's important because sometimes you may record your flow depending on the flow measurement devices. You may record your flow in gallons per minute, but it needs to be reported in million gallons per day. But all of the other parameters on this particular permit are listed as all of the other loading requirements are pounds per day, and all of the quality or concentration requirements are in milligrams per liter. So keep that in mind. All right. Want to just show you the permit for a second. It should be on the same page with the results at the top. Let's see right there.
Here.
Going up to the first one. Can you flip that? There we go. Okay, so I only mention these slides, and we can stay right here, is to emphasize that this should exactly match your DMR, or your DMR should exactly match this, because when all else fails, this is the standard that we will be held to. So if there are errors in the DMR, then we need to get that corrected. But the permit is what we're going to use for compliance. So we want to make sure that those parameters listed on the permit exactly match what's on the DMR. Okay. All right. So now we're going to switch gears just a little bit and talk about some of the actual calculations. We're going to share the screen, and I'm going to just go through some brief exercises of calculating some of these parameters on the board as much as our time will allow us. So at this point, we're going to switch to an interactive exercise. Where is it? I'm ready. Okay. So, good. All right. One of the things that I mentioned to you earlier, one of the slides, we didn't dwell on this particular slide very much, but it stated need to know information. There was some information like DO in the aeration unit, sludge settleability, the flow, max monthly, max weekly. This is information that you will get directly off of your operator log. There's no calculation to any of those things. However, when you start talking about effluent BOD, for example, or influent BOD, for example, our BOD influent for the month of April was 66 milligrams per liter. Our flow on that particular day was 0.43 MGD. Well, how do we know that? We know that because when we collected the samples, or when the lab collected the samples, the flow, the instantaneous flow, was also recorded, and it was recorded at 0.43 MGD. Well, now you say, what do we do with this information? If you look on your wastewater formula sheet, if you've got one, or if you remember your loading calculations from the certification exam, or if you happen not to be certified and you're preparing for certification exams, then we know that the loading formula is pounds per day equals milligram per liter concentration times the flow in mgd times 8.34. Well, 8.34, where did that come from? That's a constant, and it's constant to this particular formula. So pounds per day equals the concentration in milligrams per liter. I'll mention this to you, your concentration may also be given to you from time to time in parts per million. So for the purpose of this discussion, we're going to consider parts per million and milligrams per liter to be interchangeable. So our 66 milligrams per liter equals our concentration. Our flow, as previously indicated, is 0.43 mgd. Our constant is 8.34. So now it's just simply a matter of multiplying these three numbers, 66 times 0.43 times 8.34 equals 236.6892. So you may not want to write all of that 6892. So we would call that 236.69 pounds per day. 236 pounds per day. Now, I don't know that we've got time to calculate each and every single loading. In fact, I'm sure that we do not. But you've calculated that loading. That's not necessarily the loading that will go in the DMR. Because now what you've got to do is look at the other two loadings for May and June. So for example, the loading for the month of May, well, the influent for the month of May was 113 milligrams per liter. The flow was 0.47 mgd. And of course, we've got our constant of 8.34. So again, calculator work. 113 times 0.47 times 8.34 equals 442.9374. We're going to call it 442.94 pounds per day. So far, our highest concentration is the 113. Our highest loading is the 442, but we're still not sure what information we're going to enter into our DMR until we calculate the final loading, the final influent loading of June. June's BOD, influent BOD, is 117 milligrams per liter. The flow is 0.39 mgd times our constant of 8.34. And remember that 0.39 is our flow at the time that these samples are being collected. So now we calculate our loading. 117 times 0.39 times 8.34 equals 380.55. 380.55 pounds per day. Now, this is exactly the point I was hoping that we would get a chance to show. Notice that the highest concentration is 117 milligrams per liter. That's the information that will go on the DMR under quality or concentration. But if you noticed in May, the flow was a lot higher, resulting in a loading of 442.94. So on the DMR, the loading will be 442.94. The concentration will be 117 milligrams per liter. So the point here is that the highest concentration does not always equate the highest loading. You've got to run the numbers and calculate it out and factor in the flow, as was the case here. A lower concentration had a higher flow, resulting in the highest of all the loadings for that particular quarter. So if you're entering information into this particular DMR, 117 is your concentration. The loading is 442.94. Okay. Those loadings, it works exactly like that for every parameter. For the effluent BOD, for influent TSS, effluent TSS, all of the parameters that you will encounter going down in that DMR work exactly like those influent BODs that we just calculated. Now, the next thing I want to show is, for the time that we have left, is percent removal. I don't know how many of you are familiar with the percent removal formula, but it says something like this: in minus out over in times 100. In meaning influent, out meaning effluent, and of course in divided by n times 100 turns it into a percent. So when you're calculating percent removal, then this is actually a calculation that's got to be done three times and then averaged. So you've got to calculate each month's percent removal and then get an average of the three. And let me give you a quick example of what that means. In the month of April, let's just use TSS since we used BOD last time. Influent TSS was 36 milligrams per liter. The effluent TSS was 5 milligrams per liter, divided by 36 milligrams per liter. Okay. Now let's go to May. This was April. The influent TSS in May was 34 milligrams per liter. The effluent TSS was 2 milligrams per liter, all over 34 milligrams per liter. Again, influent is in, effluent is out, but we're not quite done. In the month of June, the influent TSS was 134. The effluent TSS was 5, all over 134. Now we're ready to calculate. So you may have a tendency to want to just take 1 month and do the percent removal for that month. But that won't be the percent removal for the quarter unless you factor in all 3 months. So for the month of April, we're going to say 36 minus 5 divided by 36 equals 0.86 times 100 equals 86%. For the month of May, 34 minus 2 equals 32 divided by 34 equals 94%. And finally, in June, 134 minus 5, 129 divided by 134 equals 96%. So now I would take the 96 plus the 94 plus the 86 divided by 3, and I've got a quarterly percent removal of 92%. And 92% is what I would include on my DMR after having factored in all of the months of that particular quarter. Now, again, I want to say to you that with the examples that we've provided, only 1 sample was collected during a particular month, which means that your monthly max and your weekly max will be the same. But there are situations where during the course of a week, and certainly during the course of a month, you may collect more than 1 sample, in which case those samples must be accounted for and averaged accordingly. So pay attention to that as well. I'm just about out of time. In fact, I am out of time. Avery, I want to thank you for allowing me the opportunity. And at this time, I will turn it back over to you.
Wonderful. Thank you so much, KT, for presenting with us today. It doesn't look like we have any questions. So after the session today, an evaluation will pop up. If any questions come up after the fact, feel free to add them in the comments there, or you can reach out to our small systems email and I will follow up to get that question answered. So yes, thank you, KT, for sharing your expertise. Following this webinar today, all attendees will receive the slides and a link to the recording. I mentioned that evaluation. We also ask that you let us know your feedback there and let us know your thoughts on today's session. And we'll use it to help plan our future webinars that are on topics important to you. So thank you again. And KT, do you have any last remarks today for our audience?
So just thank you for your attendance, and I hope some of the information that was presented will be beneficial to you. And if you've got questions or comments on other topics that you would like to see or elaborated on more, then we may be able to use that for future planning. So again, thank you, and thank you, Avery, as well.
Wonderful. Thank you so much, and I hope you all have a great rest of your day.